I'm now going to do page 563. I'm going to attempt to do 3 problems. I don't know how long it will get though. 61 and 62. Okay, 61 and 62 are both review. I think it's important to go through, but 55 is going to be the priority right now. At number 55, they give you a mini tab output. This is define the parameter of interest. Right now we're dealing with proportions. How do I know that? It's categorical variable. Categorical variable in this case is teens that think young people should wait to have sex until they are married. Part A says define the parameter of interest. You would say P then, because it's P, not mu, is equal to the proportion of teens aged 13 to 17 that believe you should wait and have sex until married. Part B says check the conditions. This is where we're not running, we are running random. In part B, it does say random sample, that's stated. Independence, 10 times n. You can find your little n in the output, and they actually say it as capital N in this one. So 439. Your output will never give you the population. The output of the mini tab needs to be less than capital N. This is all teens, 13 to 17. N is your normal. Don't mess this one up now with your mu's. Your normal is you're going to take your NP, so 439, needs to be times your proportion. So you have to find your proportion there. They give you an X. If you look at your book, that X is 246. That's your part out of this whole entire sample, 439. Needs to be greater than or equal to 10. And then you need to do it again. This time, though, you take 439, and you need to multiply it times 1 minus 246 over 439. This has to be greater than or equal to 10. And then you can proceed. Part C says interpret the p-value. They give you that p-value there. Okay? So you would say the p-value is 0.011, which means there is a 0.011 probability of getting, Kayla, can you get that for me? And just say student speaking. Just say, I'm making a video, student speaking. Getting a Z value approximately equal to 2.53 or greater, or more extreme, excuse me. All right, sorry, I got a phone call. You'd say the p-value is 0.011. There is a 0.011 probability of getting a Z approximately equal to 2.53 or more extreme, given the null hypothesis of, do they give us a null hypothesis? I don't know if they give us a null hypothesis. Then you would just say given the null hypothesis is true. Okay, moving on then to part D. Does the data give convincing evidence that the actual proportion differs from, oh, they do give us a null hypothesis. I'm so sorry. I'm going to erase. If part D is your null hypothesis, then you would say given the null hypothesis that P is equal to 0.5 is true. If they don't give this to you, then you just say given the null hypothesis is true. Part D says, now do we have convincing evidence that the proportion differs from 0.5? What that means is we're looking for evidence for the alternative hypothesis. When they say differs, we know that's a not equal to. The p-value should have, in a Minitab output, is always for a two-sided. I have not discussed that. I'll make sure I note that on Monday, but the p-value for a Minitab output is always two-sided. That means if it was a one-sided, you would have to divide that p-value by 2. You don't in this case, because it is two-sided. So D, your p-value is equal to 0.011. Since that is less than alpha equals 0.5, you have evidence for HA. So you would state this as, because our p-value is equal to 0.011 for a test statistic of Z is approximately equal to 2.53, we reject H naught at alpha equals 0.05. We do have evidence that the proportion of teens age 13 to 17 that believe they should wait until have sex until they're married is not 0.5. Oofda. I'm going to be done with that one.